Hello everyone, welcome in today's lesson. In today we will learn science and today's topic is kinetic energy. So now let's first what is kinetic energy? We all know kinetic energy is a fundamental concept in physics that describes the energy an object possesses due to its motion. It plays a crucial role in many physical processes and is key to understanding dynamics and mechanics. Like you can understand many kind of dynamics and mechanics with kinetic energy. The formula to calculate kinetic energy is half mv square. So we understand that kinetic energy is very important in our daily life. Kinetic energy in short form is called Ke, is the energy an object has because it is moving. It is given by the formula Ke equals to half mv square. We saw before in the last page that the formula of kinetic energy is half mv square, where m describes mass of the object in kilograms kg. The unit mass, the unit of mass is kilograms kg. Then comes v means velocity of the object in meters per second. In the next page we can see key concepts of kinetic energy. Here you can see there are 4 points: dependence on mass and velocity, units, scalar quantity, relation to work. So now let's first understand dependence on mass and velocity. 1. Mass. Kinetic energy increases with the same mass of the object. Heavier objects have more kinetic energy if moving at the same time speeds a lighter object. So we can understand by this, if the object is heavier, it will have more kinetic energy. That means if the mass of the object is more, it will have more kinetic energy. Like as example, the mass of a car, just suppose, you don't need to take seriously. The mass of a car is 1000 kilograms, suppose. Now the mass of a cycle again is 500 kilograms. So of course the kinetic energy of car will be more. Then comes velocity. Kinetic energy increases with the same square of the object's velocity. That means that if the object's velocity doubles, its kinetic energy increases by a factor of 4. This quadratic dependence on velocity makes speed changes more impactful. These things means if the object's velocity, speed doubles, then the kinetic energy will be increased by a factor of 4. Then come to next point. You can see the next point is units. Here is only one thing written. The SI unit of kinetic energy is joule. In short form it is called J. Everyone knows that the SI unit of kinetic energy is joule. 1 joule is equivalent to 1 kilogram meter squared per second squared. Then comes the scalar quantity. Now let's understand the scalar quantity too. Kinetic energy is scalar quantity, which means it has magnitude but no direction. Okay, now let's understand the scalar quantity. Kinetic energy is a scalar quantity, which means it has magnitude but no direction. Unlike vectors which have both magnitude and directions, kinetic energy is concerned only with how much energy is present, not the direction of motion. Okay, so by this we understand the kinetic energy is not dependent on the direction of the motion. It depends on how much energy is present in the object. Like it depends on its magnitude but has no direction. You have just read it before. So now let's come to relation to work. Kinetic energy is related to the concept of work in physics. Work done on an object results in a change in its kinetic energy. According to the work energy theorem, the work done by the forces of an object is equal to the change in its kinetic energy. So here we can understand that kinetic energy is related to the concept of work in physics. Means it's related to the concept of work in physics. Work done on an object results in a change in its kinetic energy. Means if you do a work and the work is done in an object, it will have a change in its kinetic energy. Then now let's come to the next page. Examples and application. Now let's first read the 3 points. There are 3 points which is everyday examples in engineering and in sports. means kinetic energy is used in many ways, but here are three examples. The first example is everyday examples. So now let's read this. Moving car. We all know moving car has a kinetic energy. A car traveling at a high speed has a large amount of kinetic energy, which is why it requires a significant amount of energy to stop it. Now, by reading this, we get to know that accidents, the car accidents, the bus accidents, all kind of accidents related to a thing occurs for kinetic energy. If the thing is in high speed, but it does not have the sufficient energy for stopping the amount of kinetic energy, then just you know what will happen actually, an accident will easily occur. Like here it is written, a car traveling at high speed has a large amount of kinetic energy, which is why it requires a significant amount of energy to stop it. Suppose a speed of the car is 360 km per hour. Now if the car does not have the sufficient energy to stop the speed, then an accident will occur. Then the next point is thrown ball. A ball thrown with a greater speed will have more kinetic energy than one thrown slowly. By reading this, we can understand speed also has a relation with kinetic energy. The more the speed, the more the energy. The less the speed, the less the energy. A ball thrown with a greater speed will have more kinetic energy. That means if you throw a ball with a high speed, like you know what, cricketers throw ball at very high speed, like 134 kilometers per hour, 100 kilometers per hour, and many more speed. I actually don't know the correct amount of speed thrown by a cricketer. So now, then one thrown slowly. That means if a ball thrown slowly, it will have less kinetic energy. Now let's come to in the use of engineering. Kinetic energy is also used in engineering. Machinery. Machines often convert kinetic energy into other forms of energy. Example, by reading this sentence, we can understand that machinery, just like machines, often convert kinetic energy. That means machines are used to convert kinetic energy. We got to know a new thing into other forms of energy. By reading this, we understand that kinetic energy is converted into other forms of energy, like wind turbine converts the kinetic energy of wind into electrical energy. Here we can understand that wind turbine converts the kinetic energy of a wind into electrical energy. For this, just for performing this, we will need wind. Then safety design. Safety features like crumple zones in cars are designed to absorb kinetic energy during the collisions, reducing the force on occupants. By reading this, we can understand when the cars are built, there is a crumple zone which can absorb the kinetic energy during collisions, reducing the force on occupants. That means it will help to reduce danger happening while doing something using with kinetic energy. Now kinetic energy also has relation in sports. Now let's read these two. Athletics. Sprinters and throwers use their kinetic energy to maximize performance, where their speed and power translate into kinetic energy that enhances their performance. This thing means sprinters and throwers use their kinetic energy, kinetic energy in their body. Kinetic energy is also stored in body to maximize their performance, to improve their performance of that sport. Like few days ago in throwing, Olympics actually happened, and then Pakistani broke the world record of throwing actually. And now let's get back to the topic, where their speed and power translate into kinetic energy. That means the athlete's speed, the athletes use, and the power they use translates into kinetic energy, means converts into kinetic energy that enhances their performance. That means that increases their performance, that improves their performance. So we can see by reading this, we can understand that kinetic energy is also helped to improve the performance of sports. Conversion of kinetic energy. Now kinetic energy is also has conversion. So now let's read this. In isolated systems, the total kinetic energy of an isolated system, one without external forces, is conserved. In collisions or interactions, the sum of the kinetic energies of the object before and after the interaction remains constant if no external forces are acting perfectly. Elastic collisions. By reading this, we can understand the total kinetic energy an isolated system has. The isolated system will be without external forces. The kinetic energy in that thing will be conserved. This thing means the kinetic energies of the object before and after the interactions remain constant. That means the thing will remain same. But there is a condition if the external forces are acting perfectly, like there is perfectly elastic collisions. Now the another point is energy transformations. Kinetic energy can be transferred into other forms of energy, such as potential energy. Example, a ball thrown upwards has its kinetic energy converted into gravitational potential energy as it rises. Or thermal energy. Friction converts kinetic energy into heat. By reading this, we can understand the friction force, the friction energy. We all know about friction force. It converts the energy into kinetic energy into heat. That means the friction force which we use in our daily life can be converted into heat by kinetic energy. Now the another thing is a ball thrown upwards has its own kinetic energy. That means if you throw a ball upwards, it will have its own kinetic energy, and that can convert it into gravitational potential energy as it rises. That means if it goes upwards, it will convert it into gravitational potential energy. In the next class of kinetic energy, we will solve problems of kinetic energy. There are lots of problems that can be solved using kinetic energy's formula. In next class, we will learn it. So thanks for watching. That's it about today's lesson. If there was any mistake in today's lesson, if I had any mistake teaching you, please correct that mistake and forgive me for any kind of mistake.